Welcome to the Dapr community call. This is June 29th. Thank you for being with us. Sorry if there's some noise in the background. Sorry about that. So today we have several items on the agenda. Yaron is going to give a pretty extensive demo of the gRPC method proxying. We got Jigar, who was going to talk to a contribution he made about just additional support for reminders and time intervals in the actors. And finally, Nick is gonna talk a little bit about the Dapr Roadmap and how we're kind of tracking it and how you can also see it and chime in. So I think with that, let's get started. We have quite a few things. Yaron, you can go ahead.
Yeah, thanks, Tori. Let me just share my screen. Let me know when it's coming through.
Yeah, we see it.
All right. Hey, everyone. My name is Yaron. I'm a Dapr core maintainer of the Dapr runtime and a few other repositories. And today we'll be talking about something that we might call Dapr Service Invocation V2 for gRPC. So let's just give a little bit of background about what gRPC is. It's a framework that was started at Google based on an internal framework that they had released as open source in March 2015. It basically allows clients to communicate with servers where you define your service methods in a file, and then you can generate some clients and stubs so that you can either implement server-side software and then call it through clients, either in streaming or unary calls, which is a request response style. It uses protobuf as the serialization. You can use other stuff, but protobuf is really the default serialization method, and gRPC was really built around it. Like I said, it has an IDL to define services. So Dapr has a bunch of limitations with gRPC that we shipped with the project just as it hit 0.1. And the first really big limitation that you see with Dapr and gRPC is that you can't use your own proto services. So at the core of the gRPC experience, users bring their own services. They generate their code based on these method definitions. And with Dapr today, that's just not doable. You need to use a proto service definition that's built by Dapr, and you have to implement that. And that negates pretty much the entire gRPC experience. And of course, that experience today doesn't support streaming. So gRPC is pretty popular for client-side and server-side streaming, and also for bidirectional streams. So if you want to do that, you can do it with Dapr today. And then the third issue is that you need to own serialization, because all of the data that's being sent with Dapr and gRPC today is just raw bytes, and you need to import the gRPC libraries for the language that you use, and you need to basically use these to serialize the data into your own structs, which is, of course, very limiting. And all of that really is with a lot of boilerplate code that you just don't need. So taking all of this into account, I encourage you to go into the Dapr repository and look at the goals that you have on the README. You can think of them like as the Dapr constitution of sorts. It's the principles and goals of the project. And the last one is for Dapr to be incrementally adoptable. And this sort of experience with gRPC, I think, stands against that. And for the next release, 1.3, we're fixing that, and we're enabling transparent proxying with gRPC that'll allow folks to basically use all of the Dapr service invocation features and bring their own services and just use gRPC the way that gRPC is meant to be used. So let's take a look at the experience that we have today. So today, and this is a Go example, but just mentally make this, like turn this into the language that you use. You basically need to register something that Dapr calls an app callback server. So instead of just registering your own server, which got generated based on your own proto services, you basically register this app callback server. And this has a bunch of methods on it. And the one for service invocation, where applications use it to basically call one another is the onInvoke method. So you need to as a developer, implement this method, which is a singular endpoint where all method invocations land on. So we have this invoke request here, and once a call comes in from a caller, you have the method name just as a string. You basically need to have like a switch statement to see if, it's a call for, say, hello or process or whatever your actual method is. And then if it's a valid call, you need to take the any proto here, which is just a byte array, and you need to manually deserialize it. So that's not the gRPC experience. So let's take a look at what gRPC looks like. I have here the git cloned examples repository from Go. It's largely unchanged. And let's take a look at a sample server and client. So this is a server, pretty simple. It's 38 lines of code. So we open a TCP port, we register something called a greeter server, which has a method that's say hello, and it's taking in a hello request. And that's basically generated from a proto service, which looks like this. So we have the greeter service, we have say hello, we have the request, and we're returning a reply, and we're just defining the service here and the two messages that are being given when you invoke the method and what's get returned. So this is all pretty simple, pretty basic. We're just starting up the server, and here we have the implementation. So we're just log printing and then pinging back, message hello, and the name that we get from the actual hello request. This is what the client looks like. So it's pretty simple. We just have a gRPC dial here. We're dialing for that connection, and then we say hello with this method here. So we have hello request, and the name is your own. So we're basically using this generated code. And this is what the generated code looks like. Developers don't touch this. This is auto-generated. And with gRPC, you basically just take this proto file and generate it to the language of your choice. Again, this is Go. Okay, so if I were just to run this with gRPC, I would basically need to have service discovery, right? Here I'm running it locally, which means I would need to start my gRPC server with a given port, and my app would need to know which port my target app is listening on. If this were Kubernetes, for example, this would be some sort of fully qualified DNS name that I would have to know in advance. But we have Dapr doing service invocation for us, which includes service discovery and other features. And so what we did in Dapr, and I'm just going to go back the slides right now before I show the actual demo. Our solution is to basically insert a transparent proxy into the Dapr runtime so that when an app calls Dapr, it doesn't call Dapr with the gRPC service that Dapr had you call with up until now. You can just use your own proto services and just change the address of your local service to be localhost for Dapr. And then Dapr basically examines the call, and it goes like, hey, is this a known API call? If it's a call meant for the Dapr APIs, just let it continue to the Dapr APIs. But if I don't recognize this call, check if there's a Dapr app ID key present in the metadata. And this is how Dapr does service discovery. So we as a gRPC client, we call Dapr just as if we were calling a non-Dapr application, but we insert a metadata that's just telling Dapr, hey, Dapr, I want you to proxy this request, and here's how I want you to discover the service on the other end. And this is the app ID of my given service. So if the metadata is not there, Dapr will just reject the request because it's not valid. And if it is, magic will happen and it'll proxy the request remotely to Dapr. So let's go back to the code here. And we can see that this is just the regular gRPC client code from the example. The only thing that's changed is this line here. And I'm just going to zoom in a little bit. So gRPC has metadata that you can attach to a call. This is like an HTTP header. And here we're basically telling Dapr, hey, Dapr, here's your Dapr app ID. And I want to discover and invoke an app called server and any of its instances, because Dapr also does load balancing on your behalf in a round robin fashion. So let's see how this works now. So I have a greeter client here. I'm going to hop in here to a different console, and I'm just going to run Dapr run. and I'm going to use the app ID of server. So I'm using the Dapr CLI to run this thing locally on my machine. I'm giving my application a unique ID, which is what I'm going to be calling from the client. I'm just telling Dapr that my app is using gRPC. I'm giving Dapr the port to proxy the calls to for my app. And here I have go run main go. So I'm just using the Dapr CLI's convenience command to just run my Go application. So this will run the sidecar, and then it'll run my app. And what's going to run here is basically just this server. So we can go ahead and run this. Okay, and we can see that our app is up and running. And now we can go into the client, and I can just run the client, which is this piece of code, which is going to just invoke say hello. So I'm just going to do dapr run, and I'm going to give it an app ID of client. So same thing, just giving my app the Dapr port that Dapr is listening on, which is this one. So here I'm setting the Dapr port, and that's it. So let's just run this. And we can see that the call went through. So I didn't call my gRPC service directly. This call was made through Dapr because Dapr now is listening on port 5007, which we can see here. And if I now go and open up Zipkin, notice that we don't have any instrumentation in our code. It's just regular gRPC code. There's no sorts of tracing or metrics here, but if I open it up here and I take a look at my application map, I can see that we get the full tracing of Dapr. And if we go here, we can see that, yeah, we have one call with this nice Pac-Man looking thing here. And we can also dig into the traces. So we can look at all the traces, and we can see the client calling the server. We can see the exact gRPC method that's being called. There's nothing Dapr specific here. This is the actual product service name that's generated from the product service that we did. There's nothing Dapr made in here. We can see the tag, the application that was called, and some more metadata that the Dapr just picks up when it does the tracing, and of course the latency and all that. So this is how it's done. But now you ask, well, what about tracing? What about streaming? How will streaming work? Well, streaming works particularly well in this case. So I'm just going to go over to a different gRPC example that we have here. And this is a streaming sample. So this is just a little bit of code. This is not my code. This is the gRPC example code. If this were my code, of course, it'd be much prettier than this. But basically what this does, and let's search for it here, it opens a stream and starts receiving messages from the stream. And then it just prints those out. And this is the gRPC client, and this is the gRPC server, where we basically iterate over a list of features, and the server streams those to the client. So yeah, I didn't mean to go here. So let's close down this example, and now I'm going to go over to the route guide streaming example, and I'm just going to do dapr run app ID. I'm going to call it stream server. So I will just run this, and our app is running with Dapr, and I'm going to go here to the client and do dapr run and give an app ID of stream client, and this is just going to work. And we can see that we got all the messages, so the streaming went through. And if we go back to our dependencies, we can also see that we have full tracing and telemetry with stream client and stream server. So if we go back to here, yeah, I should have shown the popcorn slide before. If we go back here, we can see that supported with this solution are all of the Dapr building blocks for service invocation. So you get to use your own product services. You get Dapr telemetry, which is tracing and metrics. You get Dapr MTLS, which is mutual authentication all the way through between your gRPC services. You get access lists, so you can decide which one of your services can call which other service, and you can block it by methods. You get API authentication with headers, so your clients can authenticate to the servers or vice versa. And you have support for all of the Dapr gRPC middlewares, and it can also run side by side with the old way. So if you use Dapr with the old way of doing gRPC, you can run both of these side by side, and it's not a breaking change. I will pause now and take up questions.
So I don't think we had any questions regarding the gRPC. I don't know if anybody else has anything, please drop them in the chat. Otherwise, we can also take questions at the end of the session. So Yaron, are you done then? Can we move on?
Yes, I am.
Okay. Okay, here's one question. I've tried gRPC Dapr client in Kubernetes, but never really worked. Is there any demo in Kubernetes?
Yeah, so what you tried is basically the old way. It should have worked, but the new way that's getting released in, when's the release, Ori? I think it's like July 14th or something like that. When this gets released in Dapr 1.3, we'll have documentation in place. The PR landed in master branch. So, you can pretty much repeat the experience that you've seen in the demo here, and it should just work on Kubernetes or really anywhere. But we will have documentation examples and quick starts for how to do this once 1.3 lands.
Okay, great. Thank you, Yaron. With that, I'll give it over to Jigar. I'll stop sharing and you're welcome to share.
Hello guys, my name is Zigar Gandhi, and recently I worked on a feature that has landed in master, is that to support ISO 8601 intervals for reminders. Okay, so what is ISO 8601 duration for reminders? It is like, right till now we for actor reminders we support a due time and we supported this thing, the period. Okay, so the period was of the standard Golang, time duration format like 0 hour, something like this: 0 hours, 0 minutes, 5 seconds, and 0 milliseconds. So this is what we even supported for period. But with my recent PR changed, I have added support for ISO 8601 intervals. So what ISO 8601 says, it is in this format. So we have this P, and then we can have n years, n months, days, then followed by a T, and then hours, minutes, and seconds. So along with that, we have added one more feature that you can run the reminder for n number of duration. So this is what Rn stands for, a number of times the reminder is repeated. So what will happen if you put Rn to 1? If you put Rn to 1, it will run the reminder one time and then get deleted. So this is the facility that we have added, or this is the feature that we have added to the runtime. Yeah, so the benefit is that the users, or the code does not have to, the app does not have to remember how many times they want to run the reminder, and it will get automatically deleted after it runs n times. So this n is totally optional. I mean, if it is not specified, it will run as usual. And we have not modified the existing, we have just added on to the existing format. So to show you a demo, right now on the top of my shell, I have Dapper run. I have opened this Dapper run on the top. I have modified slightly the Dapper actor sample in C Sharp because we still need to do some work in the C Sharp SDKs and all. And in bottom, you see a curl request that I'm going to run, which says repeat 7 times with an interval of 7 seconds. And I'm going to post it to a demo actor with ID ABC, and I am going to create a reminder of REM1. So let's run the app first. So it is running the app. Okay. So just give it a second. Yeah. So placement tables updated. Okay. So now you see, that it is running health checks frequently. But now I will run this the call request to post the reminder. So once I do that, you will see the reminders coming up on the top. See reminder 1. It ran one time. Okay, just give it a couple of seconds. it will run 7 times at a period of 7 seconds, and then it will stop running. Yeah, second, third, fourth, and now it should be done any second. Yeah, so you found deleting reminder because all the options, all the you know um, all the repetitions were exhausted, so it will automatically delete the reminder. So this was the feature we added to Dapr runtime recently. I know, I mean, just there might be a slight confusion here that I am not using a slash because this was on my master branch. The slash was added later on by another PR. But yeah, that's all. Any questions?
Thank you very much. I'm not
Yeah.
seeing any questions.
Yeah, Jigar, I just want to thank you on behalf of the Dapr maintainers for this. It certainly makes the actor reminders much more, predictable to people who know this ISO interval format. So that's a pretty good addition. And to those of you who don't know what Dapr actors are basically these small units of compute and state that can be distributed across the cluster. You can actually schedule tens of thousands of these inside, for example, of a single container, and Dapr manages their life cycle. So it's pretty good for IoT and gaming scenarios. I encourage you to go read up on that. And what Jigar just showed here was how we register reminders that invoke certain actors with a given ID.
Yep, and I think this way is much more flexible than I think what we had
Definitely.
previously. So this is a great addition. Thank you again.
Yeah.
Thank you very much, guys. Looking forward to contribute more.
Great. So with that, I'll hand it over to Nick. Nick, do you want to try and share a screen? Great, we see it, but we can't hear you.
How about now? Can you hear me?
Yep.
Great. Okay, yeah, so this is the Dapr Roadmap. This is a tool that recently published to help with visibility across the Dapr projects and the different repos that go into the Dapr project. And really what this is a bunch of feature capabilities that have sparked interest from the Dapr community. And so those have been moved into this project. And what we're really looking to do is to provide visibility and help with prioritization. So when a feature is moved into the roadmap project, by default, it moves into the backlog column. And we're really looking for input from the community on these features through reactions. So you can see some of these have sparked quite a bit of interest through thumbs up. And that helps the maintainers know, which features here are going to provide the most value. And so again, that goes influences priority. These are open to also being picked up by the community for the ones that are not already assigned. So feel free to contribute a proposal. And so once something has been, targeted for a release milestone or has a proposal, it will move into the plan/committed column, if appropriate. And then once it's in progress, into the development, done, and released. So those are the different stages of this project. And so, yeah, I encourage you to take a look at this project and see if any of these provide value and react on them, or pick them up and work on them.
Yeah, and just to explain what we're not seeing anything in the done yet. This is kind of a recent effort, so it kind of is targeting from 1.3 onwards, really, or after 1.2. So yeah, so things that are still in progress are still have not been delivered as part of a release just yet. But if you've been following, a little bit of how we've been trying to play with this, we have for a while been trying to give more visibility to the planning, priority, and overall roadmap information. A while ago, we kind of shared a 6 months plan. So this is the next iteration of this that Nick did a lot of work to kind of put together, and I think together with the maintainers, of course. And I think this is a fantastic way that gives a lot more detailed kind of visibility into everything that's happening. So that's terrific. Thank you, Nick. And I actually want to show a couple of things. So just kind of to continue what Nick was showing, I hope you can see my screen. We actually pinned an issue in the Dapr issues. So if you go into the runtime repository, you can see this Dapr Roadmap issue. And that explains some of what Nick just said, and links to this project, as well as kind of giving some of the guidance on how we would love the community to chime in with upvoting or just commenting and kind of explaining also what the different columns are. So also check this out. This is a little bit of an explanation of that thing. And another thing I wanted to touch on, I don't know if everybody's aware of this, but in the docs, we also, a while ago, we added a bit of a kind of a process with security issues. So, you know, it's a best practice not to really openly kind of open issues on security issues, because then they could be exploited. But security is really top of mind for Dapr. And we do want to have a process where we can really respond quickly if anything is aside from all the testing and everything we're doing and all the precautions we're taking, if just to be very reactive to things coming from the community. So if you do stumble across a security issue, please use this email to report it to the Dapr maintainers, so we can all triage it quickly and respond to it. If it's a P0, then it will probably come with a hot fix that will be released to the community. So just a reminder for this, or if you didn't know about it. So that's about that. Other than that, happy to take any other questions from the community. Anybody, any topic, anything you want to discuss or talk about? We actually have some time today. So if you feel also you rather just speak to something, then feel free to let me know. I can unmute you as well. Okay, I don't know if any of the maintainers have anything they want to discuss or bring up.
No, I'm good. I think a lot of people should be expecting the 1.3 release. There's going to be a bunch of good stuff. I encourage people to go into the milestone issue that we have in github.com/dapr/issues and find it. It should be pinned at the very top. Yeah, the gRPC proxying is nice. If you want to see HTTP proxying, by the way, please let us know. Either find the gRPC proxying issue and comment there, or open one for it, because that's also something that we're looking into.
So yeah, so this is, as Yaron mentioned, every time we're working towards a certain release, we pin an issue here that kind of links to the different milestones in the different repos where we have issues that are scoped for that release. So for example, if you want to look at the what's going to be what is happening in the CLI, for example, you can come here and you're going to see a bunch of issues. Either it's bug fixes or new features that are scoped. You can see some of them have already kind of been merged in and will show up once we release. Some of them are still being worked on. So, and that's of course just the CLI. We got one for the SDKs, for the docs, for a lot of this stuff. So that's kind of like how you can take a look at what's coming in the next release. That's the maintainers basically have even a meeting twice a week to track progress on this and see if everything's moving along. And these are also the expected times of the release. Sometimes they kind of shift a little bit. Obviously, if we find issues or if there's something big that we want to achieve and we need more time. But basically, this is what we're aiming for. So this is not like set in stone, but this is the aim for the release.
So there's a couple of questions in chat.
Okay.
So Mr. Jenks is asking, any best practices for a team that's both Java and C#? That's an interesting question. I can tell you that for myself, I worked with companies doing very large implementations of both C# and Java. You know, if you're using both, I want to tell you that, you know, on the surface of it, there shouldn't particularly be anything that you should take into consideration. Unless you're using actors and you want to move data between C# and Java and Java actors. Like that's one area where that experience might not be great, just because different programming languages have very different serialization strategies. So yeah, if you're not using actors, there isn't anything in particular that you'd need. The C# and Java SDKs are probably the most mature Dapr SDKs. So if you want to use the SDKs and not fall to HTTP or gRPC, you should feel pretty confident in that. You pretty much have full coverage of the Dapr APIs with both these SDKs. So you should be good there.
So Mr. Jack, I think you can unmute now if you want to give more details on your scenario and what you're trying to achieve.
Hi, mic check. Can you hear me?
Yep.
Okay, great. Yeah, we have two teams that come from a background of writing stuff in Java and in C#, and we're letting them stick with their languages. We're planning on doing microservices using Dapr. And so far, we're just starting to get rolling, but so far it's looking pretty solid and good.
Good, that's good to hear. Thank you.
The other question I had, if you'll permit me, was I'm trying to understand what the role of in a Kubernetes cluster, what happens during deployment, especially of PubSub, when a pod is replaced. When I do a Kubernetes deployment that replaces version, say 12 with version 13, what's the handshake there? Because obviously, if I'm trying to do zero downtime deployment, obviously there will be a time when some of the version 12s and version 13s are running simultaneously. And does the Dapr injector, sidecar injector, do anything special that I ought to know about? And is this the problem that I think it is?
So
does that make sense?
Yeah, that makes sense. A good question. The Dapr injector isn't mutating your deployments in any unnatural way. So it's just you can configure your deployment strategies, whether they're rolling updates or however you configure them with whatever surge settings you put in your Kubernetes deployments. You can just use that as it is. For PubSub, Dapr guarantees at least once delivery. So all of the Dapr components that Dapr uses for PubSub basically have this ACK-NACK type of experience where if a pod's being taken down and your app hasn't finished processing it, Dapr will basically requeue the message and that'll be replayed to the new pod that's coming up. Whether it's an existing subscriber that's using your old version, or if you have the same Dapr app ID in your new deployment, it'll pick up that message. Does that make sense? Mr. Jenks?
Oh, I think he probably muted back, so he needs.
Oh, okay, yeah, he just wrote in the chat. Yes, that makes sense.
Okay.
Yeah. Cool, thank you.
Great.
Yes, that makes sense. I just I muted myself to be polite there and couldn't unmute again. But yes, that makes sense. So basically, at some point, the message will be delivered. I won't lose messages in the process.
Correct.
But I do need to be prepared that during a rolling deployment, during a rolling update, that the message could go to the old one or the new one.
Correct, yes.
Right, and if I wanted to stop that, which isn't exactly zero downtime, I would not do a rolling deployment, and it would just shut everything down and then start them up again.
Yes.
With the new one. Okay. All right, thank you. So that's it.
All right, thank you.
I see another question about benefit of using Dapr against of Kubernetes. I'm assuming versus Kubernetes. So
Um,
Kubernetes is more of an orchestrator, and Dapr is more of a, I guess I would, a runtime that gives you a programming model. So it actually work well together. But maybe Hee-Young, you can maybe speak to it if you like that question, if I misunderstood it, or if you have additional.
Yeah, I think you made it correctly. Just we are trying to use the Dapr in a new service product, and then trying to evaluate what is the benefit again versus like Kubernetes, since we are all new to Kubernetes and also the Dapr too. So trying to understand what's the process, and also we will struggle a lot with the gRPC in Dapr in Kubernetes at the beginning, and then realize it doesn't really work. So just wondering what is your official like announcement for like what is the benefit of using Dapr like rather than poor Kubernetes deployment or the service type
So,
or microservice.
so when you use Dapr, you probably would use it as part of microservices that you run over Kubernetes. That's actually the one kind of scenario that we are, I think, most aiming for. That's like the top scenario for using Dapr. Kubernetes lets you obviously orchestrate containers and is a great hosting platform for running microservices. But when you're a developer, and that's mostly on the ops side, right? When you're a developer and you need to tackle a lot of the challenges that you got as part of writing the code for these microservices, you're going to find that if you want to write like different languages, if you want to use things like PubSub or like state stores and secret stores, and even just invoking methods from one service to another, plus the observability and security of all of that, it kind of gets complicated. So Dapr provides the building blocks or APIs that help you tackle that. And actually Dapr runs, again, like the production scenario that we see people use with Dapr is on Kubernetes. So it's actually complementary to the kind of like the apps, the development of apps on Kubernetes. So I think this is where it actually shines when you are trying to build a microservices kind of based solution on top of Kubernetes. So you can see there's a lot of documentation that we have. And let me show you. And if you go to our Dapr docs, you go to operations and hosting options, specifically Kubernetes, you're going to see a lot of stuff around running Dapr in Kubernetes. Everything from the overview on how it kind of is deployed and how the control plane of Dapr works on Kubernetes, to everything, including how to deploy it, how to upgrade it. I think one of the most important things is these guidelines, especially if you're thinking of doing a production scenario, on how to deploy it correctly so you have resiliency, high availability, and using kind of like all of the best practices that we got for running in production. And these are basically have been kind of like forged and defined by early users of Dapr who are running this in Kubernetes. And we got some great examples of people using this in Kubernetes, and you can even find some links on that on our website of some stories or use case or case studies of users using Dapr on Kubernetes in production. So hopefully that's a good start for you to kind of explore this.
One more question regarding to the cluster setup. We actually set up that Dapr in our cluster, but it needed a like admin level, the cluster admin level permission to install Dapr, and then our ops wasn't that favor of that condition. So I was wondering, like, is it going to be changed like in the future, or is it gonna be the same policy even for the upper version of the Dapr?
Yeah, good question. So Dapr uses something that's pretty common called CRDs, the custom resource definitions on Kubernetes. And Kubernetes has the concept of scoped resources and cluster-wide resources. Unfortunately or not, CRDs are cluster-wide resources, but Dapr itself does deploy and manage everything in a single namespace. So if you need to install Dapr into a Kubernetes cluster where you don't have the cluster-wide resources rights, you basically just need to give the CRDs to whoever runs the cluster, ask them to apply them on your behalf. It's like it's a one-time thing, and then you can start deploying Dapr to the namespace. So you just need the CRDs there. Feel free to reach me on Discord, and I will give you complete instructions on how to do that. But basically, only the CRDs are cluster scoped, and the rest of Dapr can be installed into a namespace where you have the rights to. Does that make sense?
Yeah, definitely. Thank you so much.
No problem.
And Paul, I saw you put something in the chat. I made you co-host, so you can unmute if you want to chime in.
Hey, Ori. Hey, everybody. Yeah, I just I was thinking about, how to contrast Dapr with Kubernetes versus Kubernetes. And one of the things I've seen people appreciate is getting those mesh-like features, whether it's service discovery, more automatic observability. When you're making service-to-service calls, you can get that tracing, and also MTLS. So those are things that I think, Dapr makes a lot easier, and it's more built in. Which you can absolutely do that in Kubernetes, but it's going to be a lot more effort and actually kind of ops work to get that going.
Yeah. Thank you for that. Moving on, I see a comment about PR reviewing in the various repos. Yaron, do you want to speak to that?
I'll speak to what, sorry?
One is asking, wondering if you could provide any visibility on when long-standing PRs will be reviewed. It is difficult to find the time to keep them updated. Thanks.
Yes. So, we want to do a better job as maintainers and improvers of the project to provide that visibility. We are working now on providing this information. We're also using some automation that's going to get kicked in to ping reviewers and maintainers, and that's obviously going to show up as a notification for the issue that you created, or if you're watching it. So we hope that's going to help. Once we have approvers and maintainers pinged, a reviewer will be assigned, and hopefully the review should kick in anywhere between like 2 days to 2 weeks. That's where we're hopeful. Currently, we have, I think, 40 PRs currently open in the project, which is amazing because it shows a lot of community participation. But of course, we could do better. Some PRs have been standing there for 2 or 3 months. So I don't have like a really good answer now. All I can say is that we are working on improving it. And thanks for bringing that up.
Yeah, this is something we're actually tracking. The number of PRs that are being opened has really exceeded, which is terrific to see. To us, it's a really strong sign that Dapr is useful and people are excited about it and want to contribute. With that being said, like our numbers of maintainers and improvers have not increased in that rate, and we're working on it. So the load is high. As Yaron said, we're trying to be on top of that, and we apologize for that. But yeah, it's just part of the growing pains, I think, of a growing community and a growing project that has reached production readiness and got people using it. So in a sense, I actually see it as a good sign that there's a lot of PRs, but of course we want to make the contribution pipeline better and be more reactive. So yeah, we'll definitely working on that, and please be patient and keep submitting and keep working on these things that we see they're terrific. Just like today when Igor showed some of the stuff that he contributed, which is a terrific contribution. That's the kind of stuff we love to see and want to encourage people to continue doing. Okay. with that, I don't see any more questions. So I think we can wrap it up for today. Thank you to the presenters for presenting. Thank you for everybody who joined us today. As always, you can find this on YouTube. Yeah, see you next time.